Alright, so welcome to the world of redox chemistry. Redox is actually, it's not an acronym, but it's the putting together of two types of equations. I don't really know the word to describe that. But the red, or the red, stands for reduction, and the O stands for oxidation. So this whole chapter is looking at reduction and oxidation reactions. Let's start with oxidation, because oxidation has a little oxy at the start. Can you think of an element that might be involved in oxidation? That's right, oxygen. So in the olden days, when scientists started researching into this area of chemistry, they focused a lot on air. And in reactions with air, or O2, we found that an oxidation reaction would occur. So have a look at this reaction here. I'm going to highlight it. Propane plus some oxygen. It lands up in this reaction that the propane gains oxygen and loses hydrogen. So they thought, it makes sense to name it oxidation because the propane gained gained oxygen. It was oxidized. Now reduction. Reduction came from the Latin word reduco. I love this because it sounds like a Harry Potter spell in real life. Reduco, and that means to restore. Because when something like this happened, this reaction here, copper oxide and hydrogen. Sorry, my dog's barking, one moment. Okay, I think my dog's okay now. So reduco. Reduco in Latin means to, whoops, that's not a pen. It means to restore. It's kind of fun, isn't it? Like, it sounds like Harry Potter. Anyway, so it'll have something that's ionic, like copper oxide, restored to just its pure elemental state. So something is restored. Oh, I wasn't going to write restored, but I did. To pure elemental state. Reduco means restore. But also they realized, it loses oxygen and gains hydrogen. However, as science progressed and we realized that chemistry is so much more than just the elements, they started to realize that redox had something to do with electrons. So have a look at this reaction here, and I'm going to write the two half reactions of this. For the magnesium, we start with magnesium metal, and then we land with the magnesium 2+. So, on the total charge on each side, we start with 0, and then here, we can't just have 2+ by itself. How do we balance it out? We need 2 electrons. So we land up with 2- on this side. So in this reaction here, magnesium lost 2 electrons. So that means that the magnesium was oxidized. And we started to realize that when substances lost electrons, they were the ones getting oxygen. So it doesn't always have to do with oxygen. Oxidation actually landed up being the loss of electrons. So see here how we lost electrons here. Now let's focus on what's happening to the chlorine here. We start with the chlorine as a gas, and then it changes to chlorine as a solid. But how did this happen? The chlorine had to gain 2 electrons. We need to balance this out. Cl-. So to balance out the charges, 2 electrons on this side. So what happened here is, since the chlorine had to gain electrons, gains 2 electrons, we say the chlorine was reduced. So what we realize here is that oxidation is the loss of electrons and reduction is the gain of electrons, aka oil rig. So the main aim of this topic is to write out these half equations here and figure out, is it losing electrons or is it gaining electrons? So oxidation is loss, I should write off electrons, and reduction is gain of electrons. Oops, of electrons. So with modern chemistry, this is now our definition of redox chemistry. Alright, so let's give this new one a try. We are going to focus on the journey of what happens to the copper. So the copper starts as copper 2 plus as a solid, and then it becomes a copper as a solid. So how does this happen? It changes from an ion to a solid, neutral solid. So on the left hand side we had a charge of 2 plus, on the right hand side we had 0. So in order to get the 2 plus to 0, we're going to add minus, we're going to add some negative charge. So we're going to add, oh, no, I just want to put the, oh my god, I don't know what to do, wait. There, the electrons are added. So 2 electrons plus copper 2 plus equals just neutral copper. So copper ions gains electrons. It is, reduction is gained, so it is reduced in a reduction reaction because it gained electrons. I'm looking at oil rig. So let's have a look at the bromine. So here's the bromine reaction. We have 2 bromide minus ions, and it turns into 2 bromine as a liquid. So on the left hand side we have a charge of -2, and on the right hand side we have a charge of 0. So to get the right hand side to a charge of -2, I'm going to add 2 electrons there, so it's all balancing out. So bromide loses electrons. Oxidized, not it is an, I'm reading, in an oxidation reaction. So can you see here, bromine loses 2 electrons. And who takes them? The copper. So it's all about balancing out. One substance will lose electrons, and then the other one will gain the electrons that are lost. So bromine is giving the electrons needed for the reduction to happen. So we say that bromine is the reductant. It is the substance that causes the other copper to get reduced. And copper is the oxidant because it is the substance that allows bromine to be the reductant. So an oxidant allows the oxidation reaction to occur, whilst the reductant allows the reduction to occur. So I guess the best way to kind of think of this is that, without bromine giving away its 2 electrons, the reduction won't happen. And without copper accepting the 2 electrons, the oxidation reaction won't happen. It's a back and forth kind of thing. They're working together. We'll have a look at some more. I know this might be a bit like, but hopefully the next one will help too. So over here, oxidation and reduction is what happens to the substance. So what happens to each thing, to the substance. Whilst oxidizing agent and reducing agent is what it does to the other side. What it does to the other substance. We'll go through some examples, don't worry. And oil rig, oxidation is loss and reduction is gain. Don't forget your oil rigs. All right, let's give this next one a try. Okay, first step is to write some half equations. So we have 4 zinc as a solid, and then it goes to 4 zinc 2 plus. So on this side, the charge is 0, and on this side, the charge is plus 8. So to neutralize the plus 8, we're going to put 8 electrons. So zinc lost electrons. All right. So if zinc loses electrons, that means it's oxidation that's happening here. It's oxidation. So that means that zinc is the reductant. It's going to cause the other substance, which is sulfur, to gain electrons. So let's have a look at sulfur. Oh, 4 of them. Can you see how I've balanced it here? Oh, don't forget your charges. Charges, charges, charges. Very important. No charge for the electrons. All right. So in this case, we have got -8 on the right-hand side as the charge. And here we've got 0. So to balance it out, let's add 8 electrons here. So what's happening here? It is a gain of electrons. So this is the reduction reaction. That means that sulfur is the oxidant, because that's what's going to get the oxidation reaction happening on the other side. So give the other reaction a try here. Give it a pause and let's see what happens. All right, here we go. So I wrote the half equations here. So in terms of the silver, we are gaining 2 electrons to make it to solid silver. So since it was a gain of electrons, the silver half equation shows it's a reduction that's happening. So the silver ion is the oxidant, because what's happening in the bromine side, or bromide, that's the ion. We have got 2 bromide ions, and then it becomes a bromide gas, and it lost 2 electrons in the bargain. So since it lost electrons, it's an oxidation reaction. So that means the Br- ion is the reductant. So I know this can be a little bit tricky to get your head around, but give it your best try. And when you come back into the class, you can ask me some questions. But otherwise, give exercise 16.1 a try. So main ideas: oxidation is the loss of electrons. Reduction is the gain of electrons. And if something is reduced, that means the substance on the left is the oxidant. And if something is oxidized, so it's lost electrons, that means the substance on the left will be the reductant.